Welcome! This will be a quite short tutorial showcasing the different Boolean operations in Rhino. One important thing to note about Boolean operations is that they require solids as the main object for Boolean operations. So make sure that you are working with solids. In here we have 4 closed extrusions. These are solids having no openings or naked edges, and to these 4 identical boxes we have also added these Boolean helpers, showcasing the different operations here. So let's go to the first one here. We can either select the primary object first and type Boolean difference, which automatically makes the selected object our primary object, the one that we want to take away material from. Or we could escape here to cancel the command, first type Boolean difference, and then first selecting the primary object, the one that we want to take away volume from, and then pressing enter or space to confirm, and now selecting the 4 volumes here that we want to subtract with, and space or enter to confirm, and temporarily hiding the Boolean helpers here. We see that this box now has had its 4 topmost corners subtracted with a set of spheres. We can show the Boolean helpers again to showcase the next Boolean operation. This one is called Boolean union. With Boolean union we can actually select the full set, all 5 of these objects, and then typing Boolean union, which will create one solidified single volume from the previous ones. The new object will be constituted by the previous surfaces, but one can also type merge all faces to make these homogeneous. With the third operation showcased here, Boolean split, one can actually use non-solid objects, in this case a surface. So we can type Boolean split, make sure that our primary object is this cube that we want to split into pieces along this surface, and then space or enter to confirm that primary object selection, and then the surface here, and then space or enter to confirm. If we hide the Boolean helpers and delete the topmost here, we see that we have made the split. One thing that one also can do, if we undo this and undo that and undo the Boolean split itself, is that if we make this into a solid by perhaps extruding this 8 millimeters, and then we can do the Boolean split command again and selecting our primary object and then the cutting surface, or in this case a cutting polysurface, then we can also, hiding the Boolean helpers layer here, we can find that we have made this thin slice of a split. Alright, as for the 4th operation here, let's show the Boolean helpers again. We may showcase the Boolean intersection command. Boolean intersection command will only retain the volume that is shared by both the A object and the B object. So we'll type Boolean intersection. The first set can be our cube here, and the second set can be this extrusion here. This retains only the volume that is shared by both geometries. Very good. There is a 5th type of Boolean operation as well, which is simply called Boolean to objects. If we undo the last operation here, the Boolean intersection, and then if we type Boolean to objects, we can select these 2 last objects again. So first one, this one, and a second one here one. Before selecting the second one may preface that the Boolean to objects command will iterate between all different Boolean operations. So selecting this first one, we have a union, a Boolean union. If we confirm this with space or enter, then we would have this unioned object. But if we click here in the viewport once more, we only get the intersection, the same one as we previously had by the Boolean intersection command. If we click once more, we have the A minus B, where the solid, where the box volume has been subtracted with the volume of the extrusion there. One time more, clicking in the viewport, we will have the B minus A, where the volume of the extrusion has been subtracted with the volume of the box. Clicking once more, we'll get an inverse intersection. And the inverse intersection, we can actually stop here. The inverse intersection is the last option here, and to showcase what has really happened here, we can hit space or enter to confirm this. And with an inverse intersection, the volume of the cube has been subtracted with the volume of the extrusion, but the extrusion has also been subtracted with the volume of the cube, giving something like this. Boolean operations may also be used to modify objects in ways which other commands do not allow. So if one would want to smooth out these 4 edges along the top here, One may use the fillet edge command here with a radius of perhaps 8 and then select these 4 edges, and one will get a convex smoothing here. But one may also do like this. If we extract surface, and if we extract the topmost surface here, we get that as a separate one. We can duplicate the border of that, and then we have that there, and then we can do a pipe of a radius of 4 millimeters then, and that is the correct one, so enter. And then we can use this solid or this box as our primary object, type Boolean difference, and then select this pipe. By deleting this pipe and deleting this curve and surface, we see that we have made a concave one here. Just one of many examples how to use Boolean operations to modify your pre-existing geometry. So that was a very brief overview of the different Boolean operations in Rhino. Thank you for your time.